Welcome to the workshop. We want to take a look today at section 3.2, probability distributions. And a probability distribution you're probably familiar with, but we're going to look at them slightly differently than we may have seen them in the past. So let's take a look at our notes. A probability distribution that we may have encountered in the past would simply be us creating a table and writing in a table what the probabilities are, which is essentially what we're taking a look at here. If you're not quite sure what I'm talking about, it should look pretty familiar when we consider an example. But to be specific and to be rigorous, we actually say that a probability distribution is a function. So if x is a discrete random variable, then the function given by f of x is the probability that the random variable takes on this particular value. Okay, f of x is the probability at that the random variable is x for each x within the range of x is called the probability distribution of x. Okay, of the random variable x. All right, so let's take a look at what this is. So referring back to example 3.1.2, that is the couple that is having 3 kids. Okay, we said that we wanted the random variable x to represent the number of girls that the couple has, and of course that random variable could take on the values 0, 1, 2, or 3 because they're having 3 kids. So let's identify what the probabilities were in each of those cases. So we have x. What are the possible values for x? We said 0, 1, 2, or 3. Excellent. And then we want to consider the probability that the random variable will take on the individual value. So let's take a look then at our notes from last time. See if I can get these open here. So last time we said that the probability of each of the individual outcomes was 1/8. And here we see there's one way to get 0 girls, 1, 2, 3 ways to get 1 girl, 1, 2, 3 ways to get 2 girls, and 1 way to get 3 girls. So we calculated the probability here that x is equal to 2, right? That the discrete random variable was 2. That is, what's the probability that they're going to have exactly 2 girls? And we found that to be 3/8. So we can take a look at our lecture notes here and say that we found this probability to be 3/8. Excellent. Let's take a look at our notes again from the previous section. If we wanted to consider what the probability is that they're going to have exactly 1 girl, then that's just this one outcome. So the probability would be 1/8. The probability that they're going to have exactly 1 girl, right? This is the probability that the random variable is equal to 1. See, there's 1, 2, 3 ways that can occur. So again, the probability would be 3/8. And then for 3 girls, that's the same as having 0 boys. There's only one way to do that. And that would be give us 1/8 for a probability. Easy enough. Okay. Let's see, I want to move this back over. So this is our probability distribution. Now, I haven't said f of 0 is, but we can do that. Our probability distribution is the function f, where f of 0 is 1/8, f of 1 is 3/8, f of 2 is 3/8, and f of 3 is 1/8. So this, right, f is a probability distribution. Excellent. Pretty straightforward, I think. So let's also give a histogram which represents this probability distribution. So let's see here. For a histogram, I need a vertical axis and a horizontal axis. And I'm going to mark on here. I've got 0, 1, 2, 3 as my possible values for the random variable. And I had probabilities of 1/8 and 3/8. So let's have that be 1/8. 2/8 would be 1/4, and 3/8. So here at 0, right, if we wanted to represent this, we wanted to give the probability as a bar that is the height of the probability. So at 0, what's the probability that we're going to have 0 girls? It would be 1/8. So we create a bar that has a height of 1/8. Now we can usually think of the bars as also having unit width, so a width of 1. So the area here would also be 1/8. All right, and then for 1, the probability that random variable takes on the value 1 is 3/8. And then the probability that the random variable takes on the value 2 is also 3/8. And then finally, the probability that the random variable takes on the value 3 is 1/8. Excellent. So here we're using the value of the random variable as the mark for the center of the bar for the histogram. You may also choose to have it be actually here, right? Have that be 0, have this be 1, that sort of thing. That's pretty common as well. But there are another couple of alternatives too. You can have a bar chart where the bars aren't actually touching. So a histogram can usually be identified, or frequently can be identified by the separation by, or no separation between the bars. Whereas a bar graph usually has spaces between. And then one more acceptable way, also typically called a histogram, is actually for us to have just a line that's the height of the probability. So there are a few different ways to give a probability distribution in terms of a graph. Okay, a couple different histograms and a bar chart is acceptable as well. All right. Let's see. I think that's it. Just one more reminder that the area inside these bars should be equal to, or can be thought of as equal to, the probability, or the heights can be. Okay, thinking of it as unit width, this area would be 1/8, this area would be 3/8, 3/8, and 1/8. And using the idea of area is a little bit better for us as we move into later sections where we consider continuous random variables, and we don't have other ways of representing the distributions. All right, so that's it for now. I'll see you guys back in the workshop very shortly.